uh, discuss about chapter 2, and we are going to focus on the forward vehicle dynamic, on the forward vehicle dynamic. Yeah. Um, so it's a very simple idea here that we wish to know the acceleration that a vehicle may have. So um, the content is given following, and we are going to focus only the first two sections. Okay, so 2.1 is about a park car on a level road. Yeah. So we are going to discuss about car in parking on a level road, right? On a level road. This is the first things we are going to discuss. We are going to discuss um, the force on the wheel, yeah, when the car is not moving, right? That is the first part, and the second part we are going to discuss uh, about a park car, uh, parked. Um, this one should be parked car, parked car on and incline, incline on the incline road. Okay, so this is the two things that we are going to discuss today, and so the first one is essentially a car that's not moved um, on this position. This will be the first thing we discuss about, and the second issue that we are going to discuss is a car on the inclined road, right? This is a example of the car on the inclined road. Yeah. So this is the second topics, and this is the first topic. So today we have a two session, and we are going to discuss both of them. And so, and the way that we are going to manage the time is it's a very simple. Um, so this is how we are going to this is how we are going to manage the time, right? So as for the time management, right? Um, yeah, for the time management, um, the first 40 minutes we will discuss about the first issue 2.1, and I'm going to give you assignment in the class for 20 minutes, and for 2.2 I will take another 30 minutes, and finally I'm going to give you assignment in class 2, right? So we are going to have a two assignment, right? So it's a very simple things, and let's start with the first one, right? Uh, let's start with the first topics. I think it's much easy for me if I move this way, right? Okay. So we start with the 2.1 here, and 2.1, it's a park car on a level road. Yeah. So it's uh, uh, park car on level on a level road. Okay, so we will start with a free body diagram, right? With a free we will start with a free body diagram, with a free body diagram, And I like to call this a free body diagram as a F and a B and a D, right? This is what we are going to call this a free body diagram, FBD. And the free body diagram of a car is very simple. So um, imagine we have a flat surface. Imagine this is a rod here. Yeah, this is a simple rod, and we have a car wheel in this side, right? And the car is facing these directions. Okay, let's assume the car is facing these directions, and at the center of the body we have this a center of gravity. Okay, this is a center of gravity of the car, and let's say this center of gravity is a C, and so we're going to use this. This is the front side of the vehicle, and we are going to use the notation X, which is the front side. And we are going to use these notations Z as the vertical direction, right? Vertical directions, and and we are going to apply this. We are going to apply this, right? We are going to apply the force. In this particular case, we have to remove the rod, right? When we remove the rod, so we can apply forces here. And this is the front wheel, and we have a two front wheels. So this is the two front wheel, and the force in the Z direction. This is a Z1. Okay, so the force, two forces. Okay, because we have a two wheel here in the Z directions, and the front wheel we call it Z1, right? And in the rear we also have two forces, F and a Z, Z2. Okay, so FZ1 and FZ2, and the distance here, the distance from this wheel um, to the center of a gravity, we call it A2, and the distance to the the distance to the front wheel, we call it A1, right? And the length, the total length, I think. So we're going to say else is A1 plus A2, and this L we call it as a wheelbase, right? It's a as a wheelbase, right? We call it as a wheelbase. It is a distance between the front and the rear wheel. And at the center, we have the weight of the vehicle, right? The weight of the vehicle is moving down here, and the weight of the vehicle is a M and G. Okay, so this is the complete free body diagram of a car. So we already has this um, complete free body diagram of a car, and now we are going to do some mathematics here. So what we are going to do next is to apply equilibrium equation, right? We have equilibrium, yeah, equilibrium equation, right? We are going to apply this equilibrium equation, right? We are going to apply this equilibrium equations to this case, such that we can obtain the force on each of the wheel. And the first equilibrium equation is just very simple. We are going to say a sigma F a Z direction equals 0, right? This is the first equilibrium equation, that the force in this direction equals 0. And going up is positive, going down is negative. So we have this one first. The one going up is a 2 FZ1 and plus 2 fz2 equal the weight, equal the weight. So going up, both of them minus going down, they should be equal, right? They should be equal. So this is um, the first equilibrium equations. And the second equilibrium equation, yeah, the second is we are going to say the moment at the c equal 0, right? The moment at the c, this is the c point up here, right? So the c point up here, so it equals 0. So we are going to obtain from here that's 2 f of z1 multiplied by a1 should be equal to f z2 times a2, right? We obtain this equilibrium of moment at this point, where the a1 is the distance from this force to the center, and and this is the other moment, right? So we have this. So it's very simple to see from here that that we can simplify this, right? We can easily see that I think I'm going to use this red one here. Okay, so it's easy that we can see we can sort of cross out the two, right? It's not that complicated to see this thing, and we can also reduce this one as that's fz1 equal, okay, equal a2 divided by a1 multiplied by fz2, right? So let's say this as equation number 1, and we are going to say this is as equation number 2. So the next is we are going to perform a simple substitution, right? We are going to do a simple substitutions. We are going to apply substitutions from equations 2, and we are going to insert this equation to equation 1, right? Okay, so the most important part is that this fz1 will goes here, right? So that it will goes there, right? So this part will replace that one, and by that we are going to obtain a much more simple formula. Okay, so here I have a 2, right? I have a 2 down here, right? So this 2 goes here, and this fz1 will be replaced by this. I'm going to multiply by a2 divided by a1 multiply by fz2 and plus this term, right? Plus 2 fz2. So here's a plus 2 fz2 equal m times g, right? So this is the equation we obtained at this point, and sorry. And I'm going to sort of simplify this term, right? Let's simplify this term, so we can essentially write this term as a 2, and divided by a1, and I'm going to maintain the a2 here, and I'm going to multiply by also a1 here, and let's put this in the brackets here. Let's put it in the brackets, and I have fz2 out, so this one equal m multiplied by g, right? So a2 goes here, we're going to put an a1 here, so it goes this way, and finally we have fz2 equal 1/2, right? Equal 1/2 of equal 1/2 of so a1 divided by a1 plus a2 multiply by m and g, right? As this is equal L, right? As I show you here up there, that's here. So as you can see, that's a1 plus a2 is equal L. So I can substitute here. I can write down that the fz2 equal 1/2 of a1 divided by L multiplied by m and g. Okay, so this is the force when the car is not moving. When the car is not moving, we have this force, right? And so this is the one of the important equation for today. And the next important equation, I think you can guess that the force on the front wheel when the car is not moving equal, it will be a2 divided by L multiplied by m and then g, right? So this is the two um, important equations that we obtained today, right? Okay. So take your time to write it down. I give you a couple of minutes to write down this equation. Okay. Now you have these equations. We are going to solve a very simple problem here. So this one we call it a normal force. Yeah, um, we call it as a normal force on the wheel, right? Um, so um, these two forces we call it as a normal force, right? They are they are normal forces. So we call it as normal forces. We call those things as normal forces on the front and rear of the wheel. Okay, so now I'm going to give you an example problem here, right? I'm going to give you an example problem, right? So let's have a example problem, all right? So let's see example problem, example. Um, so in this example, we have a following data. The front wheel is located um, around 0.78 meter, right? This is the front wheel, and the wheelbase. or the distance between the front and the rear is 2.35 meter. And we have this mass of a car is around 890 kg, right? So this is an example problem, and the question is, and the question we try to answer is, um, the question we try to answer is, um, what is the FZ1, which is the normal force on the front wheel. What is the FZ1? And we also like to know what is the FZ2, right? We like to know what is the FZ1 and what is the FZ2. Um, so we are going to solve this problem. Okay. Um, so the formula that we are going to use is the one that we already obtained before, that FZ1 um, is a half of A2 um, divided by L. Okay, I'm gonna check the equation again. Hopefully, I didn't mistakenly write here. Okay, so I think so FZ1 is A2 divided by L. So I think I got it precisely. Okay, um, here so we have um, a multiply by M multiplied by G. And we don't have a A2 up here. There is no A2, right? So we must obtain the A2 first. And because we have a A1 plus A2 equal L, it's not difficult to see that A2 can be obtained by L minus A1, right? So we can obtain the A2 here. And in this particular case, that's L is 235, so it's 2.35 minus A1 is a 0.38, right? So 38. And as a result, I obtained um, A2 is I think I'm going to have calculator here. So 2.35 minus 0.78 is 1.57 meter. Okay, so it would be 1.57 meter. Okay, so that is the F A2, and now we are ready to calculate this FZ1, which is an half multiplied by 1.57 divided by L, and L is up there, so L is 2.35, right? So L is 2.35 multiplied by the weight of the car, and the weight of the car is 910, and multiplied by a gravity is 0.1. So um, this one is the gravity, right? No, I think this one is too much. So I like to have this one is the gravity, so 9.81. And as a result of this, I got FZ1 is 2916. Okay, 2916 comma um, um, comma 5 Newton, right? So this is how we are going to get the FZ1. Now, by using the same approach here, I can obtain, say, uh, FZ2 is half of A1 divided by L multiplied by M, right? Multiplied by G. So it's easy for me to see that uh, A1 is a 0.78, right? It's 0.78, sorry, divided by L, which is a 2.35, multiplied by M, and M is 890 multiplied by 9.81. Okay, and this give us FZ2 FZ2 equal 144 um, 9.0 Newton, right? So this is the results that we are looking for, and now we can put it together and see what happened to this car, right? So the weight of the car, so the weight of the car is essentially M multiplied by G, and this one is 980 multiplied by 9.81, and we obtain the weight is just a moment. Yeah, the weight is um, the weight is 980 times 9.81, and the weight is 9,000, right? The weight is 9,613 point eight yeah, Newton. So now imagine if we have a car here, right? Imagine if we have a car, and this is the car is in here, and the force down here is a 9613,8, and from here it is two times this, two times uh, 216,5. Oh, oh yes, yes. I think you are right. Thank you so much. Thank you for your attention. I appreciate it so much. I think I make a mistake here. Yeah, I think this is not correct. So yeah. So the weight is 890. Thank you. I appreciate it so much. Let me fix it. Yeah. And uh, so 890 times 9.81 is 8,000, right? So this one gave me 8,073,9, right? So I got to change this a little bit, yeah, for the mistake I made before. So it's 8,730,9. Okay, and this one is a 2 comma, so 29, so 16,5. Um, this one would be 8 5833 Newton, and up here and this side, right? This side is it will be 1449,0 times 2. It will be 2,898 Newton, right? So as you can see, yeah, as you can see, that's uh, uh, yeah, as you can see, that's um, as you can so as you can see, the majority of the force is goes to this direction, right? So it's much heavier. uh just a moment, I think I hopefully I do it right. Yeah, So it's much heavier to decide than to decide. But if we sum them up, right? So if we sum them up, there's a two, 8, 9, 8 plus uh, 5,833. Let me check it. Yeah. Uh, uh, this side plus 5,823. It give me, yeah, it give me um, around 8,731 Newton, right? So this results is, of course, nearly the same with this result. So these results may be okay, right? So this is how we are going to um, solve the problem. So I think I'm going to blow it up a little bit for you to copy to your paper. And okay, so take your time to write down. Um, so this would be the main results, and another main results is given here. Okay. If you finish, then if you already finished, then um, um, I'm going to give you a very simple problem to solve. Okay. And uh, okay, so I'm going to share to you a problem for you to solve. And just a moment. Um, the problem that I'm asking you to solve is given following, and the window thinks. So this one, okay. So please take your time to finish this problem. Okay, so we have three problem over there. Um, please solve these problems and take a picture later on for submissions. All right. So we already learned a very simple problem, and now I like to discuss a little bit more here. So um, as you can see here, we can we can also use um, the formula for determining the positions of the center of gravity. Yeah, in some application is we like to know where is the center of the gravity located, right? And for that purpose, we are going to install a simple transducer here, a simple instrument. We call it load shell, and the load shell will tell us the data of the force, right? So if we have this force, you can use a simple balance here, right? And if you use this instrument, then you will receive the data of FZ1. And by having this FZ1 data, and you can put in this formula, you can obtain A1. Okay, so the locations of the center of gravity can be obtained experimentally, right? So that is the use of previous equation. And in addition to that, sometimes we also like to know the age, which is the height. We also like to know this the height of the center of gravity. And to obtain the height, what you need to do is you got to push the vehicle front wheel a little bit, right? And tilt or incline the vehicle. So if we have these conditions and that the tire radius is the same between rear and the front, and we ignore the suspension deflections, and the height can be obtained by this simple equation, right? So simply speaking, we can determine the x positions, the x position of the center of gravity um, by these equations, right? We obtain the x position of the center of gravity, and we obtain the z position of the center of gravity by this equation, right? So um, that is the use of the equations. Okay, now let's move ahead to a different topic, right? Let's move ahead to a different topic. So um, previously we mentioned that um, we are going to discuss these two things, right? We are going to discuss two things. Um, the first is we discuss about a vehicle in the parking position. There is no movement, and the road is level. And in this section, we understand the equation for determining the normal force, Fz1 and Fz2. So in the next discussion, we also like to know the Fz1 and Fz2 when the vehicle is inclined, right? When the road is not flat but inclined certain angle. So let's move to that discussion, right? Okay, let's move to that discussions now. Okay, I believe that's I got to move it this way, and then change the zoom to 100. Right. Okay. So now we are going to change the discussions to the second topic today. Um, so for the next topics, we are going to discuss uh, about a uh, park car on the inclined road. Yeah, on the inclined road. Inclined road. right? So um, this is the second issue that we like to discuss today, and we are interested in many things here. First, first, we like to know the formula. What is the FZ1, right? What is the FZ1? If the car is inclined, and what is the FZ2 is if the car is inclined, and the next thing is we also like to know what is the angle here. What is the maximum angle that we can park our car. um, we we like to know what is the maximum angle uh, we can park the car without sliding. And in this case, we are going to discuss for a number of cases. If we assume that the brake is on the rear brake, on the rear wheel, right? We assume these conditions. And we are also going to discuss the second condition is uh, if we use a front wheel brake, right? If we use a front wheel brake, and finally, we also like to use a four wheel brake, right? What happened if you use a four wheel brake, right? What happened if four wheel brake? I assume that we speculate at this point. Yeah, we we think that it's very likely that the maximum angle of a four wheel will be much bigger than say rear wheel, right? We assume this will happen, right? So a four wheel will have a bigger parking angles without sliding than the rear wheel. So this is our common sense. Okay, so let's start with the first one. Yeah, force, right? And of the vehicle, right? Let's draw the free body diagram. And um, this time the car is laying on an inclined road, and let's say this incline angle is pi, right? This is the angle of the car, of the road, and we have a rear wheel here, we have a front wheel here, and I think I got to better draw the car. So let's say this is the front side, and and this one is the real side. This is the front, okay? And we already know that the center of gravity will be located here. Um, the center of gravity will be located there, and so um, we know it that this is the x direction of a car, um, and and this one is the z direction of the car, right? Okay, and the center of gravity is located here, and the force will be down, right? This is m multiplied by g, and now I like to just sort of apply this force here, and also a force in this direction. And clearly that the front will be 2 of a fz1, and the rear is a 2 of the fz2, right? And if we draw this line, if we take this line, and we know that this is pi, right? I think I'm going to the center of gravity is down here, and this one will be pi angle. Yeah. So now, yeah, this is the sort of the free body diagram of a car, and it's easy to see that if we start with um, a sigma f z equals 0. If we start with this equation, and what we obtain is a 2 of fz1 plus 2 of the fz2 as precisely equal m dot g dot. This one is a sine, so this one is a cosine of the it is a cosine pi, right? So this one is the sine, this one is a cosine, so it's a cosine pi. And we also can easily see that a sigma moment at the C point equals 0, and here precisely at this point, right? Okay, so in order for the car not to move, and you will need a braking system, right? If the car has no braking system, and it will be slide down here, right? The car will move in here is no brake. So if no brake, and the car will just slide down. So we clearly need a brake, right? So we will start with a very simple brake, right? We are going to start with the rear brake, right? With the rear wheel brake, right? With the rear wheel brake, right? We are going to start with the rear wheel brake. So if we have the rear wheel brake, then the car can be hold at this place, and this is the force, right? So the rear wheel, it is a 2 and a fx2, right? So this is the braking force, right? Braking force, braking force at the rear wheel, right? At the rear wheel. Okay, at the rear wheel. And okay, so from that, I think it's easy to see that let assume this is the height, right? So if we take a moment at the c equals 0, so we are going to see that a 2 f a 2fg1, this one, and remember that the length of this, right? Remember that the length of this is a1, and the length of this is a2. So we have 2fg1 multiplied by a1 this way, and minus 2fz2 multiplied by a2, right? This direction is going to give a moment in this direction. This side is going to this way, and this one is going to that way. So we're going to say plus 2 fx2 multiplied by h equals 0, right? So we have this equation, and finally, you are going to say sigma fx equals 0, which is, and we are going to say that that's the two fx2 will be equal to m and g multiplied by sine theta. Okay, so we have a three equation here, right? We have a three equation, and and it's very easy for us to see that. Um, so from, let me see. Yeah. So from these three equation, from the three equations, we obtained, right? We obtained that um, from the three equation, we are going to obtain that fz1, right, equal um, half of the a2 divided by L. M and G, right? This one is for level rod, right? And for the not level rod, we are going to multiply by cosine pi and minus, and this half of M and G and H divided by L, and sine pi, right? And so fz2 is equal 1.5 a1 divided by L, and m dot z time sine pi, right? Sorry, I think I'm mistakenly here. Um, um, Cosine pi plus, right? So half of mg and the h and l is sine pi, right? So this is what we get, and so and one more force which is very important is fx2 equal half of m and g and sine pi. Okay, so those are the force that happen in the car. So as you can see that as you can see, if you set up a pi equals 0, right? And if you set pi equals 0, and what we are going to obtain is a fz1, fz2 of a level rod, right? Of the level rod. Okay, so if this is 0, and this will be 1, this will be 0, and in the case of the level rod, fx2 will be 0. So no braking force, right? No braking force, right? No braking force. Okay, so you got to keep in mind, this is the equations that you obtain. And now let's talk about parking, the maximum angle, right? The maximum angle, yeah, um, the maximum angle. And we are going to move a little bit here. So maximum parking angle. So let's talk about max parking angles, or incline angles, or a pi m for rear wheel braking, right? For rear wheel braking. Okay, so the maximum parking happen if this maximum parking angle happen if the if the x2 equal is the coefficient of frictions fz2. Okay, so this one is the condition of maximum frictions, conditions conditions of maximum frictions, frictions. Okay, um, condition of maximum frictions, and you can simply take this one. You can take this one, and you simply put it here, and you also take this one, and you can simply put it here, right? You take this and you put it there, and as a result, you are going to see that the tangent pi m, this is the maximum, equal a1 is a coefficient frictions divided by L, minus mu mu and h. Okay, so this one is the maximum parking angle, right? This is the maximum parking angle if you have a rear wheel brake. Okay, so for summary, yeah, for summary, so now if you have a rear wheel brake, the force, so the rear wheel, this one will receive more load, right? So as you can see, that's you can, I'm going to zoom it out a little bit. So by comparing these two, you can say more load, more load at the rear, at the rear wheel. Yeah, because of this this is negative sign, and this is the positive sign. Okay, so as you can see, that's the rear wheel will receive a more force, right? Okay, so that is the most important part for so this is a very important formula, right? Friction force, and this is the maximum friction, right? Maximum friction force here equal this. Okay, so this is the most important equation. And in addition to this, previously I think we also discussed that there's three cases we got to discuss: rear, front, and four wheel. Okay, so I'm going to give you a formula for the front and for the uh, um, so let's talk about front wheel, right? Let's talk for the front wheel. I'm going to discuss uh, for the front wheel. So now we discuss about the front wheel brake, right? Uh, front front wheel brake, right? Okay, so if the car is this, if the car is this, and the front produce this one. We produce this. So this one will be fx1, two of them. Usually, is better than rear wheel brake. Rear wheel brake. Okay. Usually is better than the rear wheel brake. So I can tell you that that the maximum of this of the rear um, is smaller than the maximum angle of the front, right? So the angle of the front parking, front parking is is a bigger than the rear wheel parking, right? You can easily see that. Okay, so now if um yeah, okay, so I think you can easily see the equation, right? um okay, yeah, so for uh so the equation also the same. The equation is practically the same. So um so the maximum angle, yeah, so the maximum parking angles is the tangents delta m equal equal a2 multiplied by mu and else minus mu h, right? Okay, so this is the front wheel. I think it's a good idea if we like to uh, compare with the with the rear wheel. Okay, so I'm going to capture this, and I will I will take this part and take also this part. Okay, I'm going to copy it, and I'm going to put it here. So just for us to see. Um, yeah. Okay. So remember that this is the rear wheel brake. Okay. Rear wheel rear wheel brake. Right. Okay. Rear wheel brake. So you can see the difference just A1 and A2, right? Okay. So depending on the A and we know which angle is usually bigger. Um, as for the best one is of course is if we have a four-wheel brake, right? If we have a now let's discuss about the four-wheel brake. So I'm going to here. Uh, yeah. So let's have a if we have a four-wheel brake. Yeah. So if we have a four-wheel, yeah, four-wheel brake. If we have a four-wheel brake, then the tangents of this um, equal mu. Okay, so this is the angled if you have a four-wheel brake, and and in addition to that, we have one more equation. I think this maybe not solvable. Plus fx2 equal half of m and g and sine theta. Okay, this is the traction force to keep the car in place, right? Okay, so you have a four-wheel brake and a rear-wheel brake, and so let me review one more time. Um, okay. Yeah, so we talk about a car on the inclined road for the rear brake and front wheel brake and four-wheel brake. This equation is this one is applicable for a front wheel and also rear wheel brake. So this two is this one is applicable, yeah, applicable for the front and also rear wheel. Okay, and also as you can see that uh, oops, this one is I think I'm going to zoom it out a little bit. Uh, yeah, these two applicable, yeah, applicable uh, for for the rear, front, and Okay, so these two equations, yeah, these two equations. This one only applicable for the rear wheel. Okay, for the front wheel, it will be slightly different. Okay, so now you have this equation um, um, for the car in inclined angle, right? Yeah, I think yeah. Um, okay, so um, remember that this is um, uh, for the front wheel brake, rear wheel brake, and this is a four wheel brake, right? Four wheel brake. So this one will be much bigger. Yeah. So I think I'm going to ask you to solve a very simple problem down here. The windows uh, here. This one will be the second the second assignment for you today. So your job is to compute the the maximum parking angle, tilting angle, and for the case of a four wheel, a front wheel and rear wheel, and you got to choose which angle is bigger. Okay. What is the question you have? Oh, okay. I will show you the slide. Just a moment. Okay. This is the picture for a four-wheel drive. Um, can you see the slide? Okay. Generally speaking, you should submit the assignment before next week. So you have around 1 week for submitting the assignment. All right. So we have reached the end of the session today, and I really appreciate your attention. And I'm going to see you again next week. Okay. Have a good time. Thank you. Thank you.